welcome back. In the last class, I started discussing about Kirchhoff's voltage law or mesh analysis or loop analysis. And in that class, we have learned that what this law says and how to apply this rule or this mesh analysis or loop analysis method to simplify an electrical circuit. And we also simplified electrical circuits. In today's class, we will be solving a few more numericals, or we will be simplifying more electrical circuits. So this is our second class on KVL. This is the concept that we have already learned in our previous class. Based on this law, we will solve the problems one by one. So let's proceed. In the first problem, it says to find out the voltage drop between M and N points in the following circuit. So the circuit, electrical circuit or network which is given, this is M point and this is N point. So what we have to do is we have to find out the voltage drop between this M point and N point. And what we can see is between these 2 points we have 3 components. One is one resistor here having resistance values 4 ohm, which is connected between M point and A point. Then between A point and B point there is a voltage source having voltage value 4 volt. And then between B point and N point there is another resistor having resistance 2 ohm. So when we will find out the voltage or potential difference between M point and N point, we have to consider all the voltage difference between this across this resistor, the voltage value of this voltage source, and also the voltage difference across this 2 ohm resistor. So we have to consider all these three resistance and their voltage values. So how we can do that? Now in this whole circuit, what we can see is we have a loop here. We already have the concept of loop or closed path, and in this loop what we can see is we have 2 resistors and 1 voltage source. And again on the other side of this circuit we have another loop where again we have 2 resistors and 1 voltage source, and this is again a complete loop or path or mesh. So in this circuit we have 2 individual loops. So by looking at the circuit itself, we can clearly understand that since we don't have any current source, and in these individual loops we have the components that we have, they are connected in series with each other. So easily we can apply KVL in these 2 individual loops. So now if we want to apply KVL in this loop, so what we have to do is first we have to assume a loop current in a particular loop and its direction. Let's for this problem, in the previous problem we took the direction in clockwise direction. In this problem let's take the direction in anti-clockwise. The direction of the current is anti-clockwise, and let's assume the value of that current is I1. And again in this loop it has to be same with the first one, the direction, and let's again it's anti-clockwise, and let's assume that current value is I2. So I1 is the current which is flowing only within this loop, and as per our assumption the direction is anti-clockwise, and I2 is the current which is only flowing within this loop, and again the direction is same, which is anti-clockwise. So let's first solve these 2 individual loops and let's find out the value of I1 and I2, and then finally we will find out the voltage drop between M point and N point. As we know that we can start traversing from any point of that loop. Let's start from this point and let's follow the direction of the current. So when we will move from A point to M point following the direction of the current, as per that the voltage that which will be dropped across this resistor, this side of that voltage drop will be at higher potential and this will be at the lower potential, since the current is flowing in upward direction. So current flows from higher potential to lower potential, as we know. So this will be at higher potential, this will be at lower potential, and with the same concept this will be at higher potential, this will be at lower potential, and the polarity of the voltage drop is already mentioned in the circuit. So now if we apply KVL in the first loop, the equation that we will get is from positive to negative when we will traverse. Let's assume that as our positive voltage. So it will be 4 I1, then for the second component it will be 2 and then minus 5, that will be equal to 0. So similarly, if we consider the loop on the right hand side, then the equation that we will develop is, suppose if we start from this point and if we follow the direction of the current, then first component that will come across is this 5 ohm resistor. So the voltage drop, and if we follow the direction of the current, which is anti-clockwise, so this will be positive, this will be negative. The polarity of the voltage source is already given, and this will be at higher potential, this will be at lower potential for 2 ohm resistor, the voltage which will be dropped across that. Now if we apply KVL one by one, if we consider the voltage values, then for the 5 ohm resistor it will be 5 I2, then for the voltage source it will be minus 10, then for the other resistor it will be plus 2 I2, and then algebraic sum of all these voltages, that will be equal to 0 as per KVL. So the value of I2 will be 5 plus 2 7, and if we take 10 on the other side it will be 10 divided by 7. So this value, so this will be 10 by 7 ampere. Now this is the individual currents that we have already found out, but finally we have to find out the voltage drop between M and N. So first, as I said, that these three components or their voltage values we have to consider. So first let's find out the voltage drop across this resistor. Now as per our direction of the current, this is a higher potential, this is a lower potential. So if we move upward, then that potential will be considered as a positive potential. So the potential drop or voltage drop that we will calculate, that will be actually VAM. So VAM value will be the current value which we have find out I1 is equal to 5 by 6, and then the resistance value which is 4. So it will be 20 by 6 volt. So that can be written as Vm minus Va. So it will be the same value but with opposite polarity, since VAM, when we are traversing from this is the current is traversing in upward direction, current is flowing. So with respect to that direction of current, this side is at higher potential, this side is at lower potential, so it will be VAM. Now if we want to find out VMA, then it will be the same value but with opposite polarity. So it will be, this side has also a resistance whose potential or voltage drop we have to find out. So as per the direction of the current, this is at higher potential, this is at lower potential. So if we write the voltage drop across this resistor, so it will be written as VBN, and that will be the current value which we have found out as 10 by 7 into resistance value which is 2. So it will be 20 divided by 7, and that much volt. So this value we can write as minus 3 point in decimal minus 3.33 volt, and this value will be in decimal 2.857 volt. Now these two voltage drops we have already found out, and this voltage value of this voltage source is already given. Now what we have to find out? VMA. So VMN we can write as VM minus VN. Now if we rearrange between M and N, there are two more points A and B, so we can write or rearrange this way: VM minus VA plus VA. Minus VA and plus VA will cancel each other, minus VB and plus VB will cancel each other. So it's basically VM minus VN only. Now if we think separately, VM, or if we separate them, VM minus VA, then plus VA minus VB, then plus VB minus VN, VMA plus VAB, then plus VBN. So VMA we have already found out. VMA is what? Minus 3.33 volt. So minus 3.33 volt plus its VAB. VAB is already given, which is 4 volt. So 4 plus VBN. VBN we have already found out, which is 2.857. So now if we think an equivalent circuit for that part, then it will look like we have a resistor, then we have a voltage source, and then again we have a resistor. So this is M. Then between both that resistor and voltage source we have the A point, then this is B point, and this is finally N point, another end point. So VMA first we have considered, then VAB, and then VBN, and this is the final value. Now let's move on to the next problem. This is another type of circuit that we have, where we have to find out the current values or loop current values in this network or circuit. Now the loop currents we have to find out, but they are not mentioned, so we can assume any direction, but whatever we assume in both the loops we have to take the same direction. So in the first loop, suppose if we assume that this is our direction of the current of the first loop, and this is the value of the current I1. So in the second loop also we have to assume the same direction. So and that value of the current is I2. Now what we have to do, and in the difference between this circuit and the other circuits that we have already solved is, in this circuit we have a current source, but with this current source we don't have any resistance connected in parallel, and this current source is present in the common branch between these two loops. So in the first loop, if we apply KVL, and before applying KVL what we can do is, since this is a current source, so we can assume that the voltage which will be dropped across this current source, that will have some value, and if we, for that voltage drop, if we assume a variable V, so easily we can apply KVL in both the loops. So across this current source, when current will flow through this current source, let's assume that a voltage will be dropped, and that voltage value is V, and since this is the direction of the current, it is flowing upward, so this will be at negative terminal of that voltage value, a voltage drop. Now in the first loop, if we apply KVL and if we start traversing from this point, then along the direction of the current, if we move or traverse, then first we come across this voltage source, and in the first loop if we apply KVL, then the equation that we can develop is, so first we are traversing from negative terminal to positive terminal, so this value will be taken as minus 20, then this will be at higher potential, this will be at lower potential, so this will be plus 6 I1, and again this is a common resistor between these two loops, so through this resistor two currents will flow, both the loop currents, so it's not only I1 or I2, it's basically the resultant of I1 and I2. Since we are in the first loop and the direction is downward of I1, the direction of I1 is downward through this resistor, so the resultant current will be I1 minus I2, and the polarity of the voltage, it will be, this will be at higher potential and this will be at lower potential. So when we will consider the voltage drop across this resistor with respect to this I1 current, this loop current, it will be written as I1 minus I2, and again we have this voltage value across this current source, so, and this is positive, this is negative, so it will be taken as plus V, and that will be equal to 0. And what we can write is 6I1 plus 8I1, it is 2I1, it will be 8I1, and if we take on the other side, then it will become minus 8I1. Then if we analyze our second loop, where the current is I2 and the direction of current is again anti-clockwise, sorry, clockwise in this problem, and the current I2 that will flow through this resistor, 2 ohm resistor, it will be in upward direction, and the current which is flowing through I1 current, when it is flowing through 2 ohm resistor, then the current direction is downward. Now if we apply KVL in this loop, and if we start traversing from any point, let's say from this point we are starting our journey and we are following the direction of the current, so it will, the voltage drop when we will consider, this will be at high potential, this will be at lower potential, and then this is already marked, and then I2 when it will flow through this 10 ohm resistor, then it will be in this direction from left to right, so it will be at higher potential and this will be at lower potential. So if we start traversing from this point, then this value, the voltage drop will be 4 into I2, and then we have this 2 ohm resistor. So resultant current with respect to I2, it will be I2 minus I1, and the net direction of the direction of the net current or resultant current will be upward through this 2 ohm resistor. So this time the polarity of the voltage source will be this, it will be at higher potential, this will be at lower potential, and the net voltage drop value will be I2 minus I1 multiplied by the resistance value, which is 2. And then next is the last component is 10 ohm resistor. Through that when I2 will flow, the voltage drop will be 10 into I2, and this is at higher potential, so this will be written as 10 I2, and then this algebraic sum will be equal to 0. So if we simplify this, then we have minus 2 I1, then we have 10 I2 plus 4 I2, 14, and we have 2 I2 here, so it will be 16 I2, and then we have minus B, which is equal to 0. So finally if we express V in terms of I1 and I2, then it will be minus 2 I1. Now in the first equation we have expressed V in terms of loop currents, and also in the second equation we have expressed V in terms of loop currents, and these two V are basically the voltage value across this current source. So this is the same parameter. So what we can do is we can equate the right hand side of both the equations. So if we do that, then what we will get is, what we can write is minus 8I1 plus 2I2 plus 20, and that will be equal to minus 8I1 plus 2I2 plus 20 will be equal to minus 2I1 plus 16I2. Minus 8I1 on the right side, then it will be plus 8I1, so we can write 6I1, and then if we take 2I2 on the other side, then it will be 16 minus 2, 14, so 14I2, and this 20 we can keep on the left side. Now if we divide by 2, then it will become 3I1 plus 7I2. So in the third equation we have 3I1 plus 7I2 is equal to 10. Now combining these two, we have developed an equation which has I1 and I2, but to simplify this equation and to find out the values of I1, I2, we need one more equation, and that we have to develop from this circuit only. Now how we can do that? One way is, if we consider this node and if we apply KCL at this node, we can easily find out or develop a relationship between I1 and I2. But since KCL has not been discussed yet in the class, and that will be discussed in the next class, so other way to think and to develop another equation involving I1 and I2 is, suppose if we think this way, that I1, the direction of the current source is upward. Finally the current which will be flowing through this branch which has this resistor and this current source, that the direction of the current will be upward only. So the net or the resultant current that we are talking about, we have assumed the loop current for the first loop as I1, and that direction is clockwise, and in the second loop also the direction of the current is I2, and that value is the direction is clockwise, and that value is I2. So if we look at this current source, then I1 is flowing downward through this current source and I2 is flowing upward. So net current value will be, as per the direction of this current source, it is upward. So with respect to this, what we can see is the I2 is flowing upward and I1 is flowing downward. So the net or resultant current will be I2 minus I1, and that value is already given in the current source, and that is the value of the current source. So it will be equal to 6. This is our third equation. So I2, the direction of this current source is upward. As per our assumption, the direction of I2 is upward and I1 is downward. So resultant current will be I2 minus I1, and that is matching, and that will be again upward, and that will be equal to this 6 ampere value. So it will be I2 minus I1 will be written as 6. So that can be marked as fourth equation. Now what we have to do is we have to simplify these two equations to finally get the values of I1 and I2. So I2 minus I1, which is equal to 6. So what we can do is we can multiply this equation by 3. If we do that, then we will get 3I2 minus 3I1, that will be equal to 18. And we already have this equation. 3I2 minus 3I1 will be equal to 18, and we already have this equation 3I1 plus 7I2, which is equal to 10. Or we can write I2 will be equal to 28 divided by 10, which is equal to 2.8 ampere. So I2 is 2.8 minus 6, so it will be minus 3.2 ampere. So that means our conclusion is the I1, which we have assumed earlier or in the beginning, that I1 is the current which is flowing in this loop, and that is in clockwise direction, and that value we have got as minus 3.2. That means actually this I1 in the first loop is flowing in the anti-clockwise direction, and in the second loop we assume that I2 is flowing in clockwise direction, and that value finally we have got as 2.8. So since it is coming positive, that means our assumption for the second loop was correct. So in the second loop, that the current which is in the second loop, current is flowing in clockwise direction. So through this current source, the 2.8 ampere will be flowing, and in the first loop the current that we assume that is actually flowing in anti-clockwise direction, and that value is 3.2. So now if we add them, 2.8 plus 3.2 in upward direction as per this ampere, which is matching with the value of the current source. So this is the solution, and this way we can solve. Now this circuit again can be solved easily by using another method. So we will also see that. Now suppose for this circuit, if we think this way, that this 20 volt voltage source is applying a current I. So first in this branch the I current will flow through this 6 ohm resistor. Then we have a junction here, and at this point this I current will be divided into two parts. So one part will flow through this branch and another current will flow through this branch. Now as we can see here, the direction of this current source is already upward. So what will happen is it will not be divided into two parts here. Instead of that, this current will come here and this will be added with this value. So finally through this 10 ohm resistor or this 4 ohm resistor, means through this branch, the current that will be flowing, it will be summation of these two currents. So voltage source which we have here in this branch, it has the positive polarity in this direction, and negative polarity is at the bottom. So current will come out through this positive terminal of the battery source. The direction of the current will be this, and the direction of the current source is already given. So these two currents will be added at this point, and then the resultant current will be flowing through this branch. So through this 10 ohm and 4 ohm resistor, the current which will be flowing, it will be I plus 6 through this 10 2 ohm resistor also this 6 ampere current will be flowing. Now if we consider the outer loop of this circuit, then what equation we can form is, if we now start traversing this, I will give you the concept of super mesh or super loop in the following class. Now in the outer loop, if we consider, if we apply the KVL, that concept, then, and if we start traversing from this point, then it will be minus 20 as per the polarity of this voltage source. Then it will be the current I is flowing from left to right, so this will be at higher potential, this will be at lower potential, so it can be written as 6I. Then in the outer loop we have this resistor, and as per the direction of the current, this is plus, this is minus, so it can be written as I plus 6 into 10, and then we have 4 ohm resistor, so it again can be written as I plus 6 into 4, and then we are coming back to this point where from we started, and this algebraic equation, this algebraic sum will be equal to 0. So now if we simplify this, it will be minus 20, so I is minus 3.2 ampere. As per our assumption, I was flowing through this 6 ohm resistor in clockwise direction, or we can say from left to right. But as per that assumption, the value that we have got for I is minus 3.2 ampere. That means actually this I is flowing from right to left, and so this is 6 ampere current which is flowing through this branch, and one part will be flowing in this direction, and that value is 3.2 ampere from right to left and minus 3.2 ampere from left to right. So if we want to find out the current which is flowing through this branch, means through this 10 ohm resistor and through 4 ohm resistor, then it can be written as, or can be calculated as I plus 6. So I itself is minus 3.2, then plus 6, so 2.8 ampere. So that means the direction of current that we assumed initially through this branch is correct, and through this branch the current that will be flowing is 2.8 ampere. That means the final conclusion is for this current source through this branch 6 ampere current is flowing. So at this point this current will be divided into two parts. One part will be flowing through this branch, and that value is 3.2 ampere from right to left, and one current will be flowing through this branch, and that current value is 2.8 from left to right. So we wanted to find out how much current is flowing in this loop and in this loop. So through 6 ohm resistor we can say that 3.2 ampere current will flow, but from right to left, and through this 10 ohm and 4 ohm resistors 2.8 ampere current will flow, and that is from left to right. Now we will move to the next problem, which is this. So here the problem statement is find out the current values through the voltage sources. Now here the voltage source means we have, as we can see here, we have 1 2 3 4 5 6 resistors and 3 voltage sources. Apparently this circuit looks bit complex than the previous circuits, but we have to simplify this circuit step by step, and we have to finally find out the currents which is flowing through this voltage sources. That means we have to find out the current which is flowing through this branch, and through this branch, whatever the direction that we will finally see. Now what we can say here is as per the diagram which is given, this point and between this point and this point there is no other component which is connected. So basically these 2 points are the same point. So we can imagine the circuit diagram as this, as if this point is connected with this, and as if this point is connected with this, and we don't have this part. Now this way the circuit may look bit simpler. Now what we can see here, I have already discussed in my earlier class the star delta and delta star conversion. Now here what we can see that in this part of the circuit we have three resistors and they are connected in delta. So one way of solving this circuit is, first we can touch or simplify this part of the circuit. We can convert this delta to a corresponding star connection, and that will make our job or our simplification much easier. So for that we have to apply the delta to star conversion formula, and finally the circuit will look like this. So instead of these three resistors, now we will be having three resistors as per this connection. So if we redraw the circuit, then we will have this part as it is in the original circuit. So we will have voltage source as per this polarity, then we will have resistor, fine, and then we will have this point and this point. These 2 points are same, and we will have this, we will no more have this resistor in between these 2 points. So what we can do is we can redraw the circuit this way, and then between this point and there will be now this point and this point, these 2 points are same point. There is no more component which is connected between them. So what we can do is, after drawing this branch, this point and this point, we can just connect them. This point means end point of this branch in the star connection. So we are joining them. So it will look like this. Then on the other side also we have one branch where we have a resistor, then we have a voltage source, and this is the polarity. This point and this point, they are basically the same point. So what we can do is we can connect them. So this part is over, this part is over, the star connection, the equivalent star connection, this part is over, and what is left is the branch what we have at the bottommost, and these 2 components are connected between this point and this point. And in our modified diagram, basically this is the point and this is the another point. So we can connect this voltage source, this resistor, and along with this voltage source. And now we have to find out the equivalent resistance values for this star connection from the given delta connection. Now how we can do that? We have to apply the formula. Now for this value, if suppose this is R1, this is R2, and this is our R3, then R1 can be found out. R1 is this resistance. So this will be, all these resistances are having the same value. So this will be 3 into 3 as per the formula, and then summation of all the voltage resistance values. So 3 plus 3 plus 3. So it will be 9 divided by again 9. So it will be 1 ohm. And now if we find out, or if we want to find out R2, then R2 is this resistance. So R2 will be again the multiplication of the resistances that we have in this circuit on both the sides. So 3, and again this is 3. So 3 into 3 upon 3, the summation of all this resistance values, which is 3 plus 3 plus 3. So it is again the same value. So it will be 1 ohm. And again if we go by the same formula, and if we find out R3, now this circuit looks simpler than this one, and what we have to find out is, we have to find out what current is flowing through this branch, and this branch. Now in this circuit, as we can see here, we have we can easily identify 3 individual loops. One loop, this is one loop, this is another second loop, and this is another loop, the third loop. So what we can do is, in this circuit we have resistances 3 plus 3, 6 resistances, and we have 3 voltage source. So we can easily apply KVL in these loops. So in the first loop, if we apply KVL, what we can do is, we have to first assume a loop current and its direction. Let's assume in the clockwise direction, this is I1, and in the second loop let's assume I2 is flowing, and again in the clockwise direction, and in the third loop let's I3 is flowing and that is again in the clockwise direction. So we already know the concept of KVL and how to apply KVL, how to find or how to develop the mesh equations or loop equations. Now it's easy. It's the way we have solved the other circuits earlier. So from the first loop, what equation we can develop is, so through this resistor the current which is flowing is in upward direction, so it will be at higher potential and this point will be at lower potential. So as per that, the equation that we will be developing is 4 into I1 then minus 2 plus, so it will be minus 5. Then through this R1 resistor, I1 and I2 both the currents are flowing, so the resultant current will be I1 minus I2. So it will be I1 minus I2 into this resistance values which is 1, and then again this voltage drop we have to consider across R3. Now I1 current is flowing through R3 and also I3 current is flowing in the opposite direction, opposite to direction of I1. So resultant current which is flowing through R3 with respect to I1, the direction of I1, the resultant current will be I1 minus I3, and the voltage drop will be as per the direction of the resultant current. It will be at higher potential and this will be at lower potential. So it will be I1 minus I3 into the resistance values which is 1, so I am not writing that, and that algebraic equation will be equal to 0. Then from the second loop, what equation we can develop is, this is our second loop. So if we start our journey from here and if we go by the direction of the current, then it will be 4I2. So 4I2 then plus 5 we have, and then through this resistor I2 and I3 both the currents are flowing, so it will be I2 and through this resistor I3 is flowing in this direction, so the resultant current will be I2 minus I3, and for that the voltage which will be dropped, the polarity will be, it will be at higher potential and it will be at lower potential, into the resistance value multiplied by the resistance value which is 1, and then we have this resistor R1. So through this I2 is flowing in upward direction and I1 is flowing in downward direction, it is flowing downward, so the resultant current will be I2 minus I1 and that direction will be upward, and because of that direction the polarity of the voltage drop will be, this will be plus and this will be minus. So if we consider the direction of the net current, then the voltage drop value will be here, this is I2 minus I1, so I2 minus I1 into resistance value which is 1, and that will be equal to 0. Suppose we want to start our journey from this point, and if we go by the direction of I3, then through R3, I3 minus I1, that current will be flowing. So the voltage drop will be in that case I3 minus I1 into the resistance value which is 1. Then next component is R2. Through that I3 current will be flowing in this direction and I2 will be flowing in the opposite direction. So net current or resultant current through R2 will be I3 minus I2. So it will be I3 minus I2 multiplied by the resistance value which is 1. Then we have this voltage source having value 20 volt, from minus to plus we will be now traversing, so minus 20, and this next we have 2 ohm resistor. Voltage drop through across that resistor will be 2I3. Now we have already developed this set of equation, and if we simplify this, if we solve these 3 equations, we can easily find out the values of I1, I2 and I3. So value of I1 will be the current which will be flowing through this 5 ohm voltage source, and value of I2 will be the current value which will be flowing through this voltage source, and value of I3 will be the current value which will be flowing through this voltage source. So if we simplify these 3 equations, if we solve, then easily we can find out I1, I2, I3, that we have already done in previous examples.